Welcome to GeoTrig. This video is on tangent lines, chords, and arcs. The essential question is, what is the relation between chords and arcs? Let's begin. So what is a tangent line? You might not have, don't remember this, but a tangent line to a circle is a line that intersects its circle at one point and only one point. So it kind of just goes by and it hits it and then just keeps going. Only one point. So the point where it hits is, we call this the point of tangency, and we form two rays. One theorem with tangent lines is if you take that line that is tangent to a circle and then you take a radius that's hitting that same point of tangency, these are going to form perpendicular angles. So that's the key part here. That line, that radius forms the hitting the point of tangency here, and that tangent line, perpendicular angles. So we can use that for some neat questions. So for the example of this one right here, if we have two tangent lines ML and MN, what is the value of x? And you know that since this is tangent, the angle right here is going to be 90, and this is also going to be 90. And what we have here is we have a quadrilateral. All those angles in a quadrilateral have to add up to 360. So 360 equals 90 plus 117 plus x. And we just solve for x. So that's going to be 180 plus 117. And if you add those up, that's going to be 297 plus x equals 360. And that means our x has to equal 63. All right. What about this one? What is the radius of circle C? Well, the radius, that's basically finding x in this case. Notice we have a perpendicular angle. And what's the neat thing with all these chords and what we do this for this lesson is there's going to be a lot of right triangles, a lot of using the Pythagorean theorem. So we have one leg that's 12, one leg that's x, and the hypotenuse is going to be x plus 8. So I can say x plus 8 squared is going to equal x squared plus 12 squared. So x plus 8 squared, if you multiply, that's x squared plus 16x plus 64 is going to equal x squared plus 144. Subtracting x squared from both sides, those just go away. And then I can subtract 64 from both sides. I'm just doing two steps at once because this is GeoTrig, and I can do that. Subtract those numbers, you get 80. So divide both sides by 16. And if you divide 80 by 16, you will get x equals 10 over 8. So you get x equals roughly 1.25. I think that math is right. Close enough. Yes, that's right. That is my value for x. Going on to the next one, tangent lines. So the tangent lines, here's some other neat property that you want to know. If you have two tangent lines BA and BC, or segments that are tangent to circle O, those segments are going to be congruent. They both connect at this point B. So let's use that for this problem. If circle O is inscribed on triangle ABC, what is the perimeter of ABC? Well, I know some of these sides are labeled, but this segment CE is going to also be 8 centimeters, and BE is also going to be 15, and AF will be 10. So adding those up, I get 10 plus 10, so I'm going to say 20. And 15 plus 15 is 30, and 8 plus 8 is going to be 16. And if you add all those up, you're going to get 66 centimeters. All right, chords. What's a chord? Chord is a segment whose endpoints are on a circle. So it's going to be this segment that's just inside of a circle. So this PQ is a chord. And there's going to be a relation between the arc PQ, so PQ with an arc, and PQ, the segment. There is a relation there, so just understand that. There's a ton of theorems here, but I'll kind of briefly go through this and explain what's going on. So, knowing there's a relation between that arc and that segment, the angle AOB and COD, if those are equal, that means those arcs are going to be equal to each other. If those arcs are equal to each other, the angles are going to be equal to each other. So the converse is true. This one down here says if you have the angle AOB and COD, then those segments are going to be equal, and that's the relation. That arc, those arcs are going to be equal, and the segments are going to be equal. Just kind of what I said that last time. This one. So if you have two chords that are going to be congruent, that means those arcs that relate to those chords are also congruent. And if those arcs are congruent, then the chords must be congruent. So there's that relationship. Let's use that stuff for this example in this diagram. If I say the circles are congruent to each other, given that BC is congruent to DF, so those are equal to each other, should have been lines up here, what can I conclude? Well, I can conclude that the arc BC would make that an arc, is going to be congruent with arc DF if those segments are congruent, or those chords are congruent. I can also say that angle O in this case is going to be congruent with angle P. So that's what I can say. Another theorem about this, what you have here is if you have two chords right here, B, A, and C, D, and there's a line that's going from the center to perpendicular and to each arc, to each chord, and they're congruent, or they're equal to each other, they'll be congruent. So follow that. A little more theorems about this. A lot's being said here. The idea is that you'd taken the diameter of the circle, and it's going to be, if it's a perpendicular bisector here, like in this case, it's a perpendicular, it is bisecting this chord, we're going to have congruent arcs here, we're going to have congruent sides of the chord, and then we're going to be using that for a lot of right triangle math. So you'll see when we do examples. Like if we tried this one, what's y to the nearest tenth? And this is where you got to use those properties to kind of figure this out. And remember, there's going to be a lot of right angles in forming those triangles. Well, you want to find this y, and you know the radius is going to be 15, but the y isn't the entire radius, it's something less than 15. Since this is bisecting chord AF, we know this must be a right angle here. That means I formed this right triangle. And this imaginary line is a radius, so it'll also be 15. So I have a triangle here. I can say 15 squared equals 11 squared plus y squared. So that's going to be 15 squared is going to be 225 equals 121 plus y squared. And subtracting 121 from both sides, these are going to cancel. You're left with 104 equals y squared. So y is going to equal the square root of 104. If we want, you know what, for our purposes, we can plug that into a calculator. If we did it to the nearest tenth, we would need to plug into a calculator. It's going to be, let's call that approximately 10.1. And that's what we got. Let's try some more examples. Pause the video. All right. If ED is tangent, so that means this is going to be a right angle. And if this is 38 and this is 90, then what's left is 90 minus 38. And that's got to be 52. So that's your answer for X. Next one. Let's pause the video. Very similar to what we did earlier. You're going to go your X plus 6. Use the Pythagorean theorem. It's going to equal X squared plus 10 squared. So that's going to be X squared plus 12X plus 36 equals X squared plus 100. Subtracting X squareds cancel each other out. Subtract X squared on both sides. Subtract 36 on both sides. You are going to get 12X equals 66. And divide both sides by 12. So X is going to equal, well, that's going to equal roughly, we'll call this 5.5. That's good enough. Next one. Pause the video. What's the length of RS here? Okay. Well, we know that PQ is 12.5, and this is equal to this, congruent with this QR. So QR is also 12.5. And RS, if I know these are both perpendicular angles and O to this point and the center to this point Q are both 9, then I know the length SR, so I could say SR, has to be congruent with PR. That's what we learned in one of the theorems. So PR is going to equal 12.5 plus 12.5, so 25. That must mean that SR, or RS, is going to equal 25. Next one. Pause the video. All right, we get a perpendicular line right here. That means this must bisect this chord LM. And if it's 14 centimeters, this must be 7 centimeters. So I've used the Pythagorean theorem. 7 squared plus 3 squared equals r squared. So 49 plus 9 equals r squared. That'll be 58 equals r squared. So square root both sides, and you're going to get r equals the square root of 58, and you pull out your calculator, and what you'll get is about 7.6 and centimeters. That's it.